In this AstroPictionary concept video, we want to go over main sequence and end product masses and sizes. Here we have an HR diagram, Hertzsprung-Russell diagram, and on the diagram we have various different stars plotted. Stars are drawn at different sizes, and they are also colored different colors. Surface color is based on surface temperature. Along the horizontal axis, increasing to the left is surface temperature. Along the vertical axis, increasing upward, is stars' luminosity. Based on their luminosity and temperature, stars are placed at different positions on the diagram. From upper left to bottom right, we have the main sequence, which are stars that are fusing hydrogen into helium in their cores. Most of the stars are actively fusing. Only the ones at the very bottom right corner have started out fusing, but now are no longer fusing. They're fusing hydrogen into deuterium, and then they just don't have enough fuel to continue, and they just die out. These are your brown dwarfs, otherwise known as your VLMs on the main sequence, your very, very low mass stars. These objects fade away, and their end product is a faded brown dwarf. The next mass category going from bottom right to upper left on the main sequence is your very low mass category, otherwise known as your VLMs. These are your red dwarfs. Notice how very red these stars appear. These red dwarfs we classify based on mass as very low mass stars. These red dwarfs we think fade into white dwarfs. All of them are still on the main sequence, still fusing hydrogen into helium in their cores. None have died yet, so we're just guessing that they die into white dwarfs. Along the main sequence, still moving up from bottom left to upper right, we have the next category, which is your LMs, or your low mass stars, and these are your sun-like stars. These sun-like stars for sure die into white dwarfs. Same thing with your intermediate mass stars. The next mass category going from bottom right to upper left, these intermediate mass stars also die into white dwarfs. Your high mass stars, your HMs though, die into neutron stars. And your very high mass stars, or VHMs on the main sequence, die into black hole stars. The very most upper left category, which is off our diagram, is your very, very high mass stars. These very, very high mass stars evolve into hypergiants, but they also die into black holes. Your very high mass stars die into supergiants and die into black holes. So that's a little bit of difference. Also notice the sizes of the stars on the main sequence. Your brown dwarfs are about the size of Jupiter. The red dwarfs are slightly larger. It's a small star. Your LMs, or your sun-like stars, are about the size of the sun. Intermediate mass stars are slightly larger. Your high mass stars are slightly larger than your intermediate mass. Your very high mass stars are larger than your high mass stars. And your very, very high mass stars on the main sequence are the largest size stars. When we look at the end products, we have the opposite case. Your very, very high mass stars on the main sequence, the very largest stars, die into the smallest end products. Black holes have the tiniest end products. Where we look at the opposite end, the bottom right-hand corner, which are your VLMs, otherwise known as your brown dwarfs, these guys are faded brown dwarfs. They started out as brown dwarfs on the main sequence, and they generally end up about the same size. They're contracting. They do have contraction going on inside of their stars. They don't have much fusion going on, so they will be a little smaller than when they were as brown dwarfs on the main sequence. So we see a trend. The end products, the most massive stars on the main sequence, die into the smallest size stars, called black holes, and size increases with decreasing mass from the main sequence. Stars that were on the main sequence as the very, very low mass stars die into our largest sized objects, which are our faded brown dwarfs. Now let's take a look at mass. We kind of hinted at mass on the main sequence because we divided the categories up into very, very low mass, low mass, intermediate mass, high mass, very high mass, and very, very high mass. If you look carefully along the main sequence of this diagram, you'll see where masses are indicated. So we just divided this grouping of main sequence stars up into categories based on their mass. Now these stars will die into smaller size products as end products, but they will also have various different masses. Let's take a look at these masses. When we look at black holes, the black hole masses are going to be generally larger than about 3 solar masses. So these stars started out as very, very massive objects on the main sequence, and they die into massive objects, but they're very small. The very high mass stars don't have as much mass as the very, very high mass stars on the main sequence, but these two also die into black hole stars of very small size, but also of a very large mass. When we take a look at the neutron stars, they started out as high mass stars on the main sequence, which is a lower mass than very high mass, and they die into neutron stars, which is a larger size end product than the very high mass and the very, very high mass. But these mass stars will be somewhere between 3 solar masses and 1.44 solar masses in general. So they're going to be less massive than a brown dwarf, but they're going to be more massive than a white dwarf. Now we already know that our intermediate mass stars and our low mass stars will die into white dwarfs. We suspect that our very low mass stars, our red dwarfs, will also die into white dwarfs. All of these stars have masses that are less than 1.44 solar masses. So you can see a trend here in end product mass. In end product mass, we see that mass decreases towards the faded brown dwarfs. The black holes have the highest mass end products. The faded brown dwarfs have the lowest mass end products. The opposite is with size. The end products of black holes are the smallest size, and the faded brown dwarfs are of the largest size. So we see that size decreases downward, but we also see that mass increases upward. Same thing as along the main sequence. So mass along the main sequence and mass as the end product go in the same direction, whereas size goes in the opposite direction for end products.